So let's start. It's going to go on now. While it's going on, you can quickly read there with me. Please concentrate, listen to what we're saying. A perfect square is a quadrilateral. Now you must just excuse that block sign there. That's just with the computer and the printer. They don't talk to each other to get the sign there. A perfect square is a quadrilateral with 4 90-degree angles and 4 equal sides. The formula to calculate the area of a square, you know this, is the area is equal to side times side, then it's side squared. Now, listen to this. A trinomial can represent a perfect square in the format ax squared plus bx plus c. So sometimes when you see a trinomial, quadratic trinomial, that is the equation or the expression for a perfect square. Right, when a perfect square trinomial is factorized, it will have two terms in a bracket with a square. So if you look at x squared plus 10x plus 25, if you factorize them, you get two brackets that are the same. Do you remember we just said we know this area is calculated side by side, which is side squared. Okay, you got that? Right. Now, I say you have the following available to complete this task. I didn't copy that part of the page for you. We're just going to do it together here. So you have a block that is x by x, the size of it. So look here, this is now x by x. That means this side is x, this side is x, this side is x, this side is x. So do you agree that will be x squared? Then you have a rectangle. These are the rectangles. Their dimensions will be x by 1. Because you know this length is x, no? And this length is 1. So it's x times 1. And x times 1 is just x. They're all the same. And then you have one more block or square that we don't see here. It's a square with a dimension of 1 by 1. Now if we look at this figure here, 1 by 1 will be a block that's this big. Because can you see there's a 1 and there's a 1. So there's the shape or the size of one by 1 block. So this is what you have. You have the x square block, you have the x blocks, and then you have the normal number blocks, the number 1, 2, 3, 4, 5, whatever. Now we say figure 1 represents an area model of a perfect square. All sides are equal and is mathematically given as x squared plus 6x. Do you see where the 6x is coming from? 1, 2, 3, 4, 5, 6x. Plus a constant. Right? The dimensions of the x boxes are x by 1 by x. That's what we just said. And the dimension of the x squared box are x by x. We just said that. Which of the figures given above will fit in the gray area to complete this square? Now, I just want to show you here. I don't know if you can see clearly. But on my ruler, you can measure as well. The x length, so this block here, is 3.5 centimeters. Now, if I look at the second block, that gray one, where I have to fill it, that block is less than 3 centimeters in a dimension. So can you all see that this one will not fit there? You are sure? Nothing about x will fit in there. And because we know the format of a quadratic trinomial, do you agree with me? We know it needs to be a constant number. Therefore, we also know that it's not going to be an x that fits in there. So we're going to say the figure that's going to fit in there will be the 1 by 1 figure. or you can write let's write the 1 by 1 square. Now, I said this is a 1 by 1 square. How many of those squares do you think do I need to fill this gap, to complete this square? Put up your hand if you think you know. Moana? No. 9 is correct. Do you all agree with that? 9. Let's see for sure, because it will extend there and these will extend here. Then I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So therefore the constant needed to complete the expression will thus be, just close that VS, it's x squared plus 6x plus 9. Now let's just look at the lengths of the square sides. Do you agree with me? This length is x. Ne? And this one is 1, and this one is 1, and this one is 1. So if I were to give the length of this side, it would be x plus 3. If I look at it on this side, it's x plus 1, 2, 3. Even if I look at it at the bottom, it's still x there, plus 1, 2, 3. And there it's also x plus 1, 2, 3. So the length of the sides will be x plus 3. Now ignoring that, let's just quickly look at the trinomial again. X squared plus 6x plus 9. If I factorize that thing, I'm going to say this one's square root, it's going to be in both brackets. And then factors of 9, that will give me 6 when I add them. What's it going to be? 3 and 3. So do you agree with me? It's going to be x plus 3 in brackets squared. So do you see that when you were factorizing, you were actually determining what the length of the side of the quadrilateral is? If it was x plus 5 and x plus 4, then we know it's not a perfect square, it's a rectangle, ne? But when you get the two of the same answers, you know that this is a perfect square. Now what we are trying to figure out of this investigation is we want to see what makes a perfect square trinomial perfect square trinomial. So if I write x squared plus 5x plus 10. Is that a perfect square trinomial? We don't know. Okay. So we're first going to try to figure out how do we know when it's a perfect square. And once we have that, I'm going to show you what we're going to do with this, completing the square. Right, say, can I please ask you to close the door? It is actually nice, the cool wind, but it's going to bother us now. Okay, so if you look at figure 2, I hope that you see that we once again have an x squared block. There it is. And we have another couple of x blocks, but can you see there are fewer of them? How many are there? 1, 2, 3, 4. Okay. And then we once again have the grey gap, which we have to complete, we have to fill it. Okay? Now I'm asking again, which figure and how many of them are needed to fill the grey area and complete the square? I will show you again. This x length is 3.5. It's too big for the grey area. What is going to fit in here? The constant numbers. Can you see that? The 1 by 1. I will show that to you by cutting it through as well. So what is going to fit in there? The 1 by 1s. And how many of them? 4. What expression does this model represent? Let's see if you can write down that expression yourself. So what expression represents that figure 2? Do you have the equation? Or the expression? It's x squared plus 4x plus 4. Now let's factorize that one. Which factors of 4 will give me 4 when I add them? 2 and 2, no? That tells me that this is a perfect square because it's the same bracket. Do you see that? Let's just look at the length of the side of these things. It's x plus 1, 2, x plus 2. X plus 1, 2, x plus 2. It's working out. Task 3. Complete the square of the expression. Use the area model to help you if you need it. Okay. I'm going to give you 10 seconds. This model is the same as the previous models. You see the x squared is just at the same place. They've given you part of the equation so you know where the x's fit into. I want you to try and draw them in and then see what will we need to complete this square. Just do it in pencil if you're afraid you'll get it wrong. Just quickly see if you can figure it out. Okay, because this length of this side is x, I know I have to divide those 8 x's between this block and this block here at the bottom because they both have a length of x. Do you see that? So I divide them equally. Here I give them 4 and here I give them 4. Okay. Which will give me my constants here. So how many constants do I need to complete this square? 16. And if I were to factorize that trinomial, let's try to factorize it first. Factors of 16, that will give me 8 when I add them. 4 and 4. And now I check my sides. X plus 1, 2, 3, 4. It works out. Alright, now I'm telling you that all of these trinomials are perfect squares. They all are. I want you to see if you can find some sort of relationship or pattern or something between the B value and the C value. Do you know where the B value is? B is the one in front of X and C is the constant. So do you see maybe there is something? I want to know if you can see it, if you can find it. Everyone try to find it themselves. If you think you've got it, just line your arm so I can see how far, who's still busy trying to find something or not. Those of you lying on your arms mustn't fall asleep. Khali, you seen the relationship? Okay, what is it? But you are lying on your arms, Khali. Khali, you need to make a decision about this subject, ne? Do you want to ask me something? No, I will ask you. It's fine. You can just sit there. Okay, what is the relationship between B and C? What? Moana? Wait. Right, Maestri has got his hand up. No, you can go. She has already had a chance to answer today. You can try to.
Half of B squared.
Very good. If you maybe didn't notice that, do you notice it now? You were using C to get B. Okay. I want you, if you were doing this as an investigation for marks, you would get full marks whether you use the B to the C or the C to the B. But I want you to write down like Raitumete said it now. Because most of the time, we are going to have this value. And we want to know what should be added or subtracted to these two terms to make it a perfect square. So I want you just to write somewhere, it's half of B squared gives you C. So if you take 18 and you divide it by 2, it gives you 9. And you square 9, it gives you 81. And you can test it for all of them. There, 30 divided by 2 is 15. 15 squared is 225. 20 divided by 2 is 10. 10 squared is 100. So it works for all of them, okay? So now without having this block figure, can you tell me what this value must be here for this 3.3.1 to be a perfect square? Put up your hands and tell me. Khali, you said that you were trying to figure it out, so now I've given it. Khali, what is that value? Khali, what is that answer? Khali, the reason I keep asking you is because I can see that you are not listening. You are not listening to a word I'm saying. You don't even get to class on time. So I don't understand why you are here if you are not putting in the effort. Pokang? 144. And then if I were to factorize that trinomial, what will be in the bracket? X plus 12 is correct. Pokang, can you please tell us how did you get to that answer of 144 in case there's still someone who doesn't know? Thank you. 24 divided by 2 is 12. 12 squared will give me 144. Who can tell me what that answer or the missing value will be there at 3.3.2? Yes? 25. How did you get to that? 10 divided by 2 is 5. 5 squared is 25. And if I factorize it, it's going to be x. Very good. Okay. So, now we know what makes a trinomial a perfect square. Do you agree with that? We can see it. If I write any trinomial here now, if I write x squared plus 12x plus 40, is that a perfect square? No, because 12 divided by 2 would be 6. 6 squared would be 36. So this is not a perfect square. Okay. So you know how to identify one. Now I want to show you how we're going to use this. This completing of a square. Now before we start with this, example where we use this method to solve equations. Do you realize and notice that when we've been factorizing in the bracket story, if you got a trinomial and you got the two brackets, using the factors of the constant to give you the middle term, you remember that one? Did you notice that the only answers we got were whole numbers or integers? Did you notice that? We never got to an irrational number. Do you know what an irrational number is? A decimal number that's never ending. So do you think we cannot get those answers? They don't exist. No, they do exist, because remember, irrational exists. Non-real, they don't exist. Okay. Do you know the difference between non-real and irrational? Irrational is an ugly decimal. Non-real is a square root of a negative number, basically. They don't exist. Okay. But when we factorize this trinomial, except for it being the side of a square, when we look at a graph, it's where your parabola, your quadratic function, cuts the x-axis. Did you know that? Okay. So there's no rule that says this must be a whole number. That can be an irrational number, but we can't factorize them now, because we can't find the factors of 5 that are irrational numbers. Do you agree with me? Okay. So this completing of a square makes it possible for us to get the irrational answers as well. Not non-real. Non-real don't exist. If I were to show you what non-real roots look like, graphically it would look like that. Can you see the parabola is not cutting the x-axis? So there can't be any roots. But it happens that you can factorize it and they're not nice numbers. They are irrational. Okay. But to do this, I'm going to use a one that will give us a rational number, okay? Just to keep it calm, not with all the decimal numbers. So we'll use a normal one. So we're going to go through the steps. First step says get the equation in standard form. So that one's not in standard form. Now I'm going to have to take the 3 over. Then I'd have x squared plus 8x minus 6. I bring that 3 over as well. It's minus 3 equal to 0. And then I can still calculate it to be simpler. It's going to be minus 9 equal to 0. Now, if you were to factorize this one, you would be able to do it. Let's just see factors of 9. That will give me 8 when I subtract. 9 and 1, very easy. You see, they will be able to factorize. But now we're going to factorize it using complete the square. Okay. So the first thing you're going to do is determine and add the constant needed to complete the square. Subtract the same value from the current C value and keep the equation in equilibrium. That sounded like a lot. I'm going to do it with you now. Tell me, is this trinomial a perfect square? No. What should that third number be for this to be a perfect square? 16. Okay. So if I could change it and I could add 16, then that is a perfect square. Do you agree with that? But if I just add 16, this equation is not equal anymore. Do you agree with me? If I was on a scale, I've added 16, the scale is tipping. So I've changed this. And I'm not allowed to change the equation. So what I'm going to do, look at this now, is I put 16 kilogram on the scale And then I subtract 16 kilograms from the scale as well. Do you see what I did? I added the 16 there so that those three make a perfect square, and I'm subtracting it there so that I didn't change the equation. Does that make sense to you? Okay? And you agree I didn't change it. Now these three terms are what it's all about. You can just write here, they're asking what is this value, it's 16, you know why, ne? These three terms are now a perfect square. So therefore I can rewrite them as x plus 4 squared. X plus 4 squared is x squared plus 8x plus 16. Do you agree with that? And then what is minus 9 minus 16? Minus 25 equal to 0. Now they say here in the steps, take the simplified constant value to the right hand side. And then it looks like this. So the next step says take the square root of both sides. Now do you remember the homework that you did on Friday? We had the square root, then we squared both sides. Now we've got the square, now we're going to take the square root both sides. But you must just remember when you take the square root on this side, it cancels out the square. And when you take the square root of 25, it will give you plus and minus 5. Ne? The square root of 25 is positive and negative 5. You must just remember that. And now we need to solve for x. So I've actually got two equations. I've got x plus 4 equal to 5 and x plus 4 equal to negative 5. And then I take that 4 over and subtract it. So I've got x equal to 1 and x equal to negative 9. Before we started, we said we can factorize that thing normally, ne? It would be x, and then factors of 9 that give me 8, it's 9 and 1, it's plus 9 minus 1, and when you take them over, the answer will be x equal to negative 9 and x equal to 1. Can you see this is exactly what I just got using the complete the square method? Now I want you to try it for 4.1. X squared plus 4x. You're going to add something. You write the minus 32. Then you're going to subtract the same thing. You need to get it to be equal to 0. Then you know your first three, they're the perfect square. The next part, you take it over. You square root both sides. Remember when you square root the number, you get two answers. And then you've got your two equations to find the value of x. Quickly do that one by yourself before we go to the next page. Okay, I've done it here on the board. Do you agree the magic number you should have added is 4? That's an odd one, eh? But remember, it's only because half of 4 is 2. And 2 times 2 is 4, and 2 squared is also 4. That doesn't normally happen. Okay? So I add it and I subtract it. Otherwise, my scale is going to tip. Then these 3 make out the perfect square. I write it as the bracket square. Then I add those two. It's minus 36 equal to 0. And I take the minus 36 over. It becomes positive 36 on the other side. Then I square root both of them. And I know I've got two answers, plus and minus 6. And then I solve for x and find the values to be 4 and negative 8. Do you all understand that? Were you able to do it by yourself? Okay. Now these ones, these two, both of them, we didn't really need this method. We would have been able to factorize them with the normal haki-haki. But now, if you look at 4.2, it says leave your answer in the simplest search form. Do you know what that actually means? It means you cannot factorize it with the bracket. Let me show you why. Can you think of factors of 5 that will give you 12 when you add them? Can you see it's not possible with the method we had? But with the method we just learned, we can find this answer. We can find the roots of this one. And we can even determine whether there will be roots or not. Okay, so I'm going to do this one with you. We'll do it together. So I'm going to write x squared plus 12x. Then I'm going to leave a space open after my plus, and then I write plus 5 again, and then I write minus, and then equal to 0. Do you know where that plus and that minus is coming from? Yes, because I know I'm going to add something and also subtract it. Who can tell me what is that thing that I'm going to add and subtract? 36. How did we get to 36? Squared. These three terms now make out a perfect square. A perfect square is a trinomial that you can put in a bracket with a square, where you take the first one square root and the last one square root and you put in the sign. Just saying, if that sign in front of 12 was a negative, it would be negative between your two terms. Okay, you know that from grade 9, but I'm just saying that. Right, when I do this calculation, plus 5 minus 36, that's going to give me minus 31. Now I'm going to take the square root both sides, né? The root and the square cancel out, né? Okay, now the difference between this one and the previous ones was at this stage I could calculate the square root of 36 in the previous one. And I could calculate the square root of 25 in the one before that. But now calculating the square root of 31 is not possible for me without the use of a calculator. Take out your calculator. Is the square root of 31 allowed? If it's not allowed, it would say math error on your calculator. Is it allowed? When would it not be allowed? If it was negative whatever. But the square root of 31 is allowed. It's just an irrational number. A decimal that's never ending. That's all there is to it. So when you write that answer, you must still write positive and negative square root of 31. You see, the negative's not inside. If it was inside, it's not real. I want the negative value of the square root of 31. So if I were to write this in an exam, and I can leave it in surd form, I'm going to say the answer is positive negative 31, or square root 31, minus 6. Now just to show you, if I hadn't asked for surd form, it would mean you take your calculator and you would type into it, and you're going to do it now. I will show you here on the board as well. Calculator. I'm going to say the square root of 31, get out of the root, minus 6. And then it gives me an answer like that, but you know how to convert it, ne? That S to D button right there, just above the delete. Then it gives me an answer of negative 0,4322. So I'm going to round it off to one decimal. It's negative 0,4. Do you understand why you couldn't calculate this answer with your haki? Okay? And that one, the second answer, I'm going to say negative the square root of 31. I just want to show you, you see it's allowed. You see it's allowed. Negative, because the negative is on the outside. Right? But in any case, minus 6. And it gives me again that funny way. So I just press the convert button. And therefore I know my answer is negative 11,6 rounded off to one decimal. So now I can factorize anything. It doesn't just have to be a whole number. Now let's see how smart you are. We're not going to do 4.3 now. When do you think, what do you think is going to happen that's going to indicate that there are no roots? Because now there are trinomials that can't be factorized. We can factorize when they are nice numbers, rational numbers, and we can factorize them when the roots are irrational. So when they're cutting rational numbers at 5 and negative 2, for example, irrational at negative 2,159 and negative 5,36, what? But we can still not factorize it when they don't exist. How would you know they don't exist? Looking at this method that we just see here. Who wants to try? How would you know that they don't exist? When you take this value to the right hand side, and it was positive here, it has to become negative there. Because then you're going to have to take the square root of a negative number, and then you're going to get a math error. And then you know, this graph exists, it just doesn't cut the x-axis. Good observation, Kumo. Do you understand that, grade 11s? Okay, so your homework for tomorrow is going to be the following. You need to listen carefully. On page 29, you are going to do exercise 5. Listen to me before you leave. Exercise 5, A, B, and C. Just the 3 of them. You have to factorize it by using this completed square. And then, listen to me, what I want you to do for tomorrow as well, so you've got those 3 sums. I want you to do task 5, but only this one on page 5. So don't go to page 6, okay? Just try to work through it so long, then tomorrow I'm going to do it with you. But this is what happens, we're going to see what happens if it has a coefficient in front of x squared. Okay, so work through it, please. Even if it seems, if you feel you don't know what's going on, just try to work through it. We're going to look at it tomorrow. Asseblief.